Aiming for higher ACT math score? Then this series will help you a lot. In this lesson, I'll show you how to solve ACT linear equation step by step manually, and then I will also show you how to solve them using Desmos, the built-in calculator of the digital ACT. Desmos can solve nearly 80% of ACT math questions, and if you know how to use it properly, it can save you a lot of time during the exam. The examples in this video may look simple, but as the topics get harder in the upcoming lessons, I will show you more powerful strategies and Desmos tricks that can make your difficult questions much more easier. What is a linear equation? A linear equation is an equation where the variable has power 1. No squares, no cubes, just a straight line relationship. I repeat, a linear equation is an equation where the variable has power 1. The ACT test linear equation because they measure algebraic accuracy, logical steps, and speed under pressure. Your goal is always the same: isolate the variable. That means getting x alone on one side. Now let's see few examples how we can isolate the variable and find its value. On the screen, you can see I have written an equation, and that is 3x plus 7 equals to 22. Now to solve this, first we have to isolate the variable. So first, remove the constants. So we subtract 7 from both sides. So now we can write 3x, let's cancel out 7, positive 7, negative 7. So 3x equals to 22 minus 7 means 15. So 3x equals to 15. So now we can divide the entire equation by 3. So that now we can cancel out 3, and 15 divided by 3 means 5. So our answer is x equals to 5. Now let's solve an ACT standard example, and that is 5x minus 8 equals to 2x plus 13. If you want, you can pause this video and try to solve this problem. So if you are done, now it's my turn to solve this problem. So first, I will solve this problem manually. Then I will show you how you can solve this problem in Desmos. So first, let's subtract 2x from both sides. So now you can write 5x minus 2x. It means 3x. 3x minus 8. And on the right side, we can cancel out this 2x. So 3x minus 8 equals to 13. Now we have to remove this constant negative 8. So to remove this negative 8, we can add 8 on both sides. So now we can cancel out negative 8 with positive 8. So we can write 3x equals to 13 plus 8 equals to 21. So 3x equals to 21. So now we can divide both sides by 3. So 3x divided by 3 and 21 divided by 3. So 21 divided by 3 means 7, and we can cancel out this 3. So x equals to 7. Now let's discuss about few common mistakes. Students move terms across the equal sign and forget to change signs. Do not move number manually. Always perform the same operation on both sides. This avoids careless errors. Now let's review those maths again. First, we remove the constant from both sides and we get 3x equals to 15. Then to isolate the variable, we divide both sides by 3. Then we get x equals to 5. Now if you can remember, during that math, we have subtract 2x from both sides and add 8 with both sides. But there is another technique, which I called gather the troops. Here, on the right side, 2x is positive. So let's make it negative, and 8 is negative on the left side. So let's make it positive. So then we gather the troops, means we can combine similar terms. So let's subtract 2x from 5 and let's add 13 with 8. Then we can get easily 3x equals to 21. Then if we divide both sides by 3, that's it. We'll get our answer. Now let me show you how you can solve the problem on Desmos very easily. Just put the equation on Desmos, and the equation is 3x plus 7 equals to 22. And if you take the pointer of the mouse on the point where it intersects, you will get the answer. That's it. And the value of x is 5. Got it? Now let's solve the second problem. And the problem was 5x minus 8 equals to 2x plus 13. Let's put that on Desmos. As like the previous example, in our second example, we just also have to put the equation on Desmos. And if we move our cursor, we'll get our answer. It's as simple as that. Got it? If you want to see what's going on behind the scene, then you just need to put both of the equations separately. Still, you will see that the value of x is 7. Here, we don't need to think about the value of y. In our upcoming videos, we'll discuss about this. Now, let's jump on our next topic. And now we'll learn SAT most favorite topic, variable on both sides. And our first example is 4x plus 6 equals to 2x plus 18. Our first goal is bring variable one side. And to do this, we have to subtract 2x from both sides. Now let's subtract 2x from both sides. So 4x minus 2x means 2x, so 2x plus 6. And on the right side, after cancelling out both of these 2x, we'll get 18. So 2x plus 6 equals to 18. Now let's subtract 6 from both sides, and then we can cancel out both of these 6. So we'll get 2x, and if we subtract 6 from 18, we will get 12. So 2x equals to 12. Now let's divide both sides by 2, and we can cancel out these 2's. So 12 divided by 2 means 6. So x equals to 6, and this is our answer. Now I will show you how you can solve that same problem on Desmos within few seconds. Just put the equation on Desmos, then move your mouse on the intersecting point, click on that, and you can label this on the Desmos graph. And here our answer is 6, as you can see on the screen. Now let's see some tricky example. 5x plus 3 equals to 5x plus 10. Now let's subtract 5x from both sides, and then we can cancel out all of these 5x. Now we'll get something which is practically impossible, and that is 3 equals to 10. Now 3 can never be equals to 10. This is impossible. So the equation has no solution. Always remember, if variable cancel and you get false statement, it means no solution. Now let's solve the same problem on Desmos. Just put the equation and let's see what happened. Oops, we can't see anything on the graph. Now let's apply separation technique. Left side of the equation in box 1 and right side of the equation, let's put it in box 2. As you can see, we get two parallel lines. So there will be no intersecting point. It means there will be no solution. Now let's see second type of tricky example. 3x plus 6 equals to 2 times 3 over 2x plus 3. Now we can write 3x plus 6 equals to, wait, on the right side we have to multiply 2 with 3 over 2x plus 3. So we can write 2 times 3 over 2x plus 2 times 3. Now on the left side of the equation, we can write 3x plus 6 equals to, on the right side, we can cancel out these 2's. So 3x plus 3 to the 6, so 3x plus 6. So left side, 3x plus 6. On the right side, it is also 3x plus 6. Now let's subtract 3x from both sides. And then we can cancel out all of these 3x. Then we'll get 6 equals to 6, and which is always true. So there are infinitely many solutions. The SAT loves testing this idea. Now let's solve this math again on Desmos. Just put the equation on Desmos. Oops, still you can't see anything. Nothing is happening. Now let's apply separation technique. Now after applying separation technique, we get two lines. One is red and one is blue. and both are overlapping each other. It means there are infinitely many solutions. Got it? Now let's review those maths again. Our algebraic approach was subtracting 5x from both sides. And at the end, we got 3 equals to 10, which is a false statement. So it means no solution. And on our visual representation, which we got from Desmos, we got two parallel lines. It means no intersection. In short, parallel lines means no intersection, and no intersection means no solution. Now let's talk about our second math. At the end of our algebraic approach, we got 6 equals to 6, which is a true statement. So it means infinitely many solutions. And if we talk about visual representation, which we have seen on Desmos, we got two identical lines. It means infinite intersections. Identical lines means infinite intersections and it means infinite solutions. Now we will learn how to solve equation with parentheses. Now our first problem is 2 times x plus 5 equals to 18. So our first step is distribution. So we have to multiply 2 with every term inside the parentheses. So let's multiply 2 with x and then we'll multiply 2 with 5. So 2 times x means 2x and 2 times 5 means 10. So 2x plus 10 equals to 18. Now we can subtract 10 from both sides. So let's do it. So on the left side, we'll get 2x. And on the right side, if we subtract 10 from 18, we will get 8. Then we have to divide both sides by 2. Now let's cancel out these 2's. So, and let's divide 8 by 2. So we'll get x equals to 4. Now I will show you how to solve the same problem on Desmos within few seconds. Just go to Desmos, put the equation, move your cursor to the intersecting point, click on it, and that's it. You'll get your answer. As you can see on the screen, our answer is 4. Now let's solve a little bit tricky math. And the question is 3 times quantity x minus 2 plus 4 equals to 16. Here, the tricky part is the negative 2. Students forget to distribute the negative. And if we properly distribute, we'll get 3x minus 6. I repeat, minus 6. If we multiply 3 with negative 2, we'll get a negative 6. So 3x minus 6 plus 4 equals to 16. Minus 6 plus 4 means minus 2. So 3x minus 2 equals to 16. Now let's add 2 on both sides so that we can cancel out this 2. So if we cancel out this positive 2 and negative 2, we can write 3x equals to, on the right side, we have to add 16 with 2. So 3x plus 2 equals to 18. Now let's divide both sides by 3 so that we can cancel out 3. And 18 divided by 3 means 6. So x equals to 6. As you can see, if you try to solve this problem manually, you have to be very conscious and alert about parentheses. Now, I will show you how you can solve the same problem on Desmos within few seconds. On Desmos, you don't need to worry about positive sign, negative sign, parentheses. While typing the equation on Desmos, you just have to be alert. That's it. Just put the equation on Desmos, you will get your answer. Now, let's review those maths again. First step was distribution. We multiply 2 with every term inside the parentheses. Then we get 2x plus 10 equals to 18. Then we subtract 10 from both sides and we get 2x equals to 8. After that, we divide both sides by 2 and we get x equals to 4. Now let's talk about this math. In this kind of math, students sometimes forget to multiply every term inside the parentheses. Always remember, distribution applies to all terms inside parentheses. Now let's solve some ACT style trick questions. These questions test your understanding, not difficulty. And our first question is from fraction. And the question is x over 3 plus 2 equals to 7. To reduce mistakes, we remove fraction early. Here, the denominator is 3. So we can multiply the entire equation by 3. Now let's multiply. 3 times x over 3 plus 3 times 2 equals to 3 times 7. Now we can cancel out these 3's. So x plus 3 times 2 means 6. So x plus 6 equals to 3 times 7 means 21. So x plus 6 equals to 21. Now let's subtract 6 from both sides. And then we can cancel out both of the 6. So x equals to 21 minus 6 means 15. So x equals to 15. Now I will show you how you can solve the same math in Desmos within few seconds. Let's type the equation on Desmos. X over 3 plus 2 equals to 7. Oops, why we can't see anything? Let's zoom out a little bit. Here we go. We find our answer. Just click on it. And you can also label it. Click on it. That's it. And our answer is 15. See how easy it is? Our next question is 2 times x over 5 equals to 6. As our previous example, we have to multiply entire equation by 5. So let's multiply. 5 times 2 times x over 5 equals to 5 times 6. So after cancelling out 5's, we can write 2x equals to 5 times 6 equals to 30. It means 2x equals to 30. Now let's divide both sides by 2. Now we can cancel out both of these 2's. So x equals to 30 divided by 2 means 15. So x equals to 15. Now let's solve this on Desmos. First, we have to type the equation on Desmos. 2 times x over 5 equals to 6. Then we'll little bit zoom out and we get our answer. And our answer is 15. Now let's solve our last math problem. And the problem is 7 minus 2 times quantity x minus 1 equals to 3. As there is a negative sign before 2, we have to distribute very carefully. As we have to multiply negative 2 with x and negative 2 with negative 1. So we can write negative 2 times x means minus 2x and negative 2 times negative 1 means plus 2. So 7 minus 2x plus 2 equals to 3. Now let's combine 7 with 2. So we'll get 9. 7 plus 2 means 9. So 9 minus 2x equals to 3. Now let's subtract 9 from both sides. Now we can cancel out these 9's. So we'll get minus 2x. And on the right side, if we subtract 9 from 3, we'll get negative 6. So let's now cancel out these negative signs from both sides. Now we can divide both sides by 2. And then we can cancel out both of these 2's. So let's do it. So, and 6 divided by 2 means 3. So x equals to 3. Now we'll solve the same problem on Desmos. Just type the equation 7 minus 2 times quantity x minus 1 equals to 3. Move your cursor to the intersecting point. Click on it, label it. That's it. You can see your answer. And here the answer is 3. Now let's review those maths again. For fraction, the strategy is very clear. And that is we have to clear the denominator immediately. As the denominator was 3, so we multiply entire equation by 3. And our second method was 2 times x by 5 equals to 6. As this is a fraction, we have to treat it like a fraction. So we multiply both sides by its denominator, which is 5. So we multiply both sides by 5. Now the math becomes very easy. Now this was our last math. Watch this slide very carefully. Pause the video and watch this slide very carefully. We multiply negative 2 with x. So we get negative 2x. And then we multiply negative 2 with negative 1, which means positive 2. Then we combine like terms. Here, like terms are 7, and 2. We combined it, we got 9. Now you can solve this math very easily. If you are solving linear equation, if you are in doubt, then graph it out. Always remember these three lines. Parallel lines means never touch. So you will get zero solutions. Intersecting lines cross once, so one solution. Overlapping lines, it means same line, infinite solution. Got it? Students usually lose points because of three reasons. Sign errors, skipping steps, distributing incorrectly, rushing easy problems. The SAT often hides easy algebra inside long questions. If your algebra is clean, these become free points. In the next video, we'll move to systems of equations, one of the most important topics in SAT math. And I will show you both manual solutions and Desmos methods. If you want to master the digital SAT step by step and learn the smartest way to solve problems during the exam, make sure to subscribe to the channel and follow this full SAT math series. Thanks for watching and see you in the next lesson.